Hello, how are you doing? Mohammed Forgas here with a lecture on concrete mixture design and proportioning. Now, we want to do a mixture design and proportioning. And for this, we need to consider multiple factors. In fact, we want to make a concrete and specify proportion of the components that goes inside our mixtures. And we want to make sure when we proportion these components, our concrete is placeable. It has the desired mechanical properties. If an engineer specifies certain compressive strength, for example, we want to make sure after we make this mixture, the resulting concrete have the desired mechanical properties. We want to make sure that this concrete is durable when, for example, it is exposed to freeze and thaw cycles because of the weather. And of course, we want to make sure the concrete that we are making is economical. We know that the cement is the most expensive component that goes inside our mixture, and it is almost 60% of the cost of the concrete. So we want to make sure that we put as little as possible, but enough cement inside our concrete. Before proceeding with this lecture, I would like to mention that many of these slides have been reconstructed from the works from the slides by Professor Jason Weiss, who is currently at Oregon State University, and some of the components in this set of lectures is borrowed from the work of Professor Ken Hover, who is currently at Cornell University. All right. ACI, or American Concrete Institute, provides a document and revises that document every so often that provides some guidelines and suggestions for how to make a concrete. And in fact, those are logical and straightforward steps that we need to follow to make our concrete. These steps, of course, are designed so that we make our concrete using the available material, local material. Now, there are a lot of documents published, and they are revised every so often that provides a very comprehensive review of the process and practice of mixture proportioning. And that if you are interested, you can go to the website of American Concrete Institute, ACI, and access some of those documents and read a little bit further. So these straightforward steps are summarized here as 10 steps that we will follow. These are the 10 steps for concrete mixture proportioning. The step number 1 is assembling the information. We want to make sure that we have the information about the local material that needs to go inside the concrete. We also want to make sure that we know the specification. For example, what is the specified compressive strength of the concrete, whether there are limitations on the amount of cement that goes, for example, what is the minimum cement content that requires to be inside the concrete, and so forth. We will go through all of these steps in detail. Then we want to select the workability of our concrete, and we use slump as a measure of workability. As I mentioned, the so-called placeability of our concrete, and that is step number 2. Then we go to step number 3, that we want to choose maximum size of the aggregate. Now, here we need a little bit more, of course, information about, for example, the type of element, the rebar, the spacing between the rebar, and so forth. We then go to estimate the water and air, select the water to cement ratio, and determine the amount of cement, estimate the coarse aggregate, determine the fine aggregate, and finally, adjust for moisture and conduct trial batches and do any necessary adjustments to that if required. So, now, here is a plan for our lecture. The plan is that we go through the 10 steps. Now, in practice, it might look like that we start from step 1 and we finish at the step 10. However, throughout this lecture, we will do something a little bit more interesting. And we will follow Universe's plan. After each step, we will stop. We will talk about the theory of the step. We provide a little bit more information. And along the way, we also solve an example. I have identified all the slides that are related to example with this red ribbon on the right-hand side of the slide. So whenever you see a slide that has this red ribbon, means that we are solving our example. So you have to pay close attention, and you will see some of the slides are repeated. They are mainly repeated because we are in the example mode. All right, let's get started with step 1, assemble the information. All right, these information, a portion of these information comes from specification and local materials. Now, job specification, whenever we want to do a mixture proportioning, we have to be aware of the job specification. And generally, job specification provides information such as specified compressive strength, F prime C. What is the maximum water to cement ratio? For example, owner of the facility or owner of the structure that you are designing this mixed proportion might specify a certain maximum water cement ratio, or the maximum water cement ratio might be specified because of the exposure condition. We will talk about those. Are there any minimum amounts of cement in that? What is the required air content? What is the specified slump or workability? What are the dimensions of the members that we are casting? Casting the concrete, and what is the cover and spacing of the reinforcement, and so forth, that you will see in a second. That all of this becomes very important in selecting the maximum aggregate size. And also, we want to make sure that we know whether any other cementitious, supplementary cementitious materials such as fly ash and silica fume is allowed. Are there any limitation to the use of those supplementary cementitious material? All of this information comes from job specification. Then we have to assemble the information of the local material. Again, we want to make the concrete with local material. If you are making concrete in North Carolina, you do not want to bring aggregate from Alaska. It's a long way, and it will be very expensive. So we want to know the information about our local material. What is the specific gravity of the cementitious material, the cement that we are going to use, or other cementitious materials such as fly ash and silica fume. Aggregates are very important at this portion of this course. You're familiar with how to measure many of the properties of the aggregate. So we need some of these information for concrete mixture design, for example, maximum aggregate size, dry rod at unit weight, and all of those. And we want to know what is the absorption of the aggregate at SSD condition, for example, and what is the moisture content of this aggregate when it goes inside the mixture. In addition, we want to make sure that we know additional information if we want to use any admixtures that wants to go inside our mixture. All right. After assembling the information about the local material, then we need to assemble the information about exposure condition. We want to make sure that we know what kind of exposure or what kind of environment the concrete is exposed. Is the concrete exposed to any salt water? Are we putting salt on this concrete? You can see over here that in this picture we are putting so much salt on this bridge deck that my blood pressure goes up by just looking at the amount of salt. I don't need to even intake it. Is the concrete exposed to freeze and thaw cycle? Do we have sulfate exposure? For example, if this concrete is placed as a foundation inside the soil, does the soil has excessive amounts of sulfates that might deteriorate the concrete? So we need to assemble all of these information. And finally, we need to know a little bit about our facility that will produce the concrete for us. Is this facility has a record of producing such concrete before or not? If they have, how much data they have and how long they have been doing producing such concrete mixture. So really that is the entire material that we need to collect in step number 1. Here is an example. you will see that I have identified these examples by a slightly different color in the title, and again, our red ribbon is appearing over here that says that we are solving an example. Okay, so in this particular example, we want to cast a reinforced concrete beam. The exposure condition is moderate, and I will talk about what does it mean when we talk about a moderate exposure in a second. And the maximum aggregate size specified as 1.5 inch in this particular example. And sometimes you will see that you will be given the dimensions of the member, and then you have to determine what is the maximum aggregate size for your particular application. And the specified compressive strength of the concrete in this case is 3,500 psi. And the table over here on the right shows all the information about the local material that we want to use to make this concrete mixture. For example, over here, the specific gravity of cement is 3.15. For those of you who want to remember this, remember pi is equal to 3.14, and specific gravity of cement is awfully close to that. So now you will remember that. Now we have assembled the information about our fine aggregate, about coarse aggregate, and the density of those, a fineness modulus of a fine aggregate, the dry rotted unit weight of our coarse aggregate, and so forth, and moisture absorption and moisture content of our local material is given over here. Now we want to use this material to cast a reinforced concrete beam. Now let's go to step number 2. The step number 2 is selecting the slump, or which we use it as a measure of workability of the mixture. So what is a slump? So let me describe how the slump is actually measured. There is a specific cone for slump measurement that looks like the one that's shown in the picture, and you will use this in the laboratory. And we fill this cone from the top with concrete in 3 different layers, 1, 2, and 3. And every time that we put a little bit more concrete into this, 1/3 at a time, 1/3 of the volume at a time, we rot this 25 times. So we consolidate this a little bit, in fact. So you can see, for example, over here that this concrete has been placed in the cone. And after that, we remove the cone, and we remove the cone very slowly. You don't want to vibrate this cone while you're pulling it out. And we measure the amount of slump, the drop in the height of this concrete mixture. That is what the slump is. And of course, you would, as you can already guess, the more workable the concrete would be, the higher the slump it would have. Over here, we can see a slump of a concrete that is, if I were to guess, I would say something around 9 to 10 inches. And over here, the slump is something around 1 to 2 inches. And you can see, of course, that the concrete over here is a lot more workable. And I will correct that in a second. I will discuss a little bit more about the workability and consistency. So this is how we measure the basically slump of the concrete, and we use this as a measure of workability for a material. Now, so after saying that we use this slump as a measure of workability, I have to tell you that really slump is not a property of the mixture. A slump is only a measure of consistency. In fact, you can have 2 different concrete materials that are completely differently proportioned, but they have the same amount of slump. Or you can have the same concrete and you can add a little bit of admixtures such as a high-range water reducer to it, and the slump of that will increase significantly. So we use the selection of slump as one of the steps in mixture proportioning, but it is very important that you realize that a slump is not an intrinsic property of the mixture. It is a measure of consistency. To make sure that you realize this, I'm going to tell you a story with 3 randomly selected pictures on this slide. And some of you are already wondering what is the relationship of these 3 pictures on this slide. We can see over here that 2 gentlemen are measuring the slump of a concrete before it is being placed on the bridge deck. And over here we see a ship. Now, the relationship of this ship to the slump is that during the World War II there was a severe shortage of steel. And people started to make ships out of concrete. And that was when the measurement of slump was created. The slump measurement was created at that point as a measure of consistency of the mixture that ship producer, concrete ship producer were receiving, and they wanted to make sure that they all have the same consistency. Now, after that, it has been standardized, and today we use it widely. But again, the take-home message is that it is not an intrinsic property of the material. We use as an almost arbitrary step as a measure of workability inside for our concrete. And the name of this ship happens to be Le Chatelier, after the chemist Le Chatelier, who for the first time measured the shrinkage, chemical shrinkage of cement, Portland cement. So for those of you who were wondering why we have a 3rd picture over here, this is because the name of this ship is Le Chatelier. So the take-home message over here is that the slump is not an intrinsic property of the mixture. It is only a measure of consistency. Here are the table from ACI 211 that provides some suggested slump for different applications. For example, if we are casting a beam or reinforced concrete wall and column, the suggested slump is something between 6 to 4 inches. Now these numbers are in millimeter, and the numbers that are inside the parentheses are in inches. That is identified over here. If we are making a residential construction, generally you want a concrete that is something between 6 to 4 inches that has a 6 to 4 inches of slump. So if we are making a mass concrete over here, we want to have something between 4 to 2 inches of slump. And again, all of these suggestions. Now, it is very important over here that we provide a mixture that is as workable as possible. So my recommendation to you would be that to use a higher range of the suggested slump for your concrete. For example, in the case of reinforced concrete beam, the suggested slump is between 4 to 6 inches. Generally, you would be better off if you use 6 inches in these cases, because if you don't get the slump right, someone else will, and you don't want that to happen. And I will talk about that a little bit. So we use this table from ACI 211 to select slump for our concrete mixture. So here we are on an example slide, and in step number 2, we want to select slump for our concrete. We said that in this particular example, we want to cast a concrete beam. In this case, we have to choose something between 4 to 6 inches, and in this particular example, we will go ahead and use 6 inch of slump for our concrete. Pretty straightforward, very easy. Now, what happens if we give a concrete mixture to a contractor that is not workable, that is very stiff, and has a very low slump? In those cases, what they will do is they will open the water to your concrete, and that is a big no-no. We do not want to add water to the concrete that we have proportion, because the properties of that will change. The durability of that will change. So this is I hope at this point you realize that this is a joke. Don't worry about the slump. If you don't get it right, the contractor finisher will. Meaning that if you give them a very stiff concrete, they will add water to it. You do not want that to happen. So it is very important that you realize this and you provide a concrete that is workable and placeable. Another thing that I would mention is that if you do not have a whole lot of information that what kind of slump you need, the recommendation is that you get a 6-inch slump or 150 millimeter slump for your concrete material. Rule of thumb, ROT over here means rule of thumb. For every, if we add 10 pounds of water per cubic yard of concrete, the slump of concrete will increase 1 inch. You can see that with addition of only a little bit of water, 10 pounds of water to 1 cubic yard of concrete, the slump of that will increase quite a bit. Again, the takeaway from this is that you do not want anyone to tinker around with the mixture at the job site to try to get the slump and make it workable. And what you will realize if you spend a little bit of time in industry, you will realize that the concrete trucks are like camels, and they hide water in funny places. And if the concrete mixture is too stiff, they will use that water. You do not want that to happen. So I will stop over here, and I will be back with another lecture covering the rest of these steps. I'll see you very soon.